Here are a few things, interesting things about what happens in the very center of our own galaxy. So you might remember the center of the Milky Way lies at about, what was it, 25,000 light years away from us. That is the sun, right? And in the direction of constellation Sagittarius. That region of the sky does not look particularly special to our unaided eyes because there is a thick veil, right, of dust. However, if we could remove the interstellar dust that obscures our view, the galaxy's central bulge would be one of the night sky's most spectacular sights. So it turns out that when we peer into the heart of our galaxy with radio and infrared, you see here in radio, we're actually zooming in, okay, we get to find that within 1,000 light years of the center, we find a swirling clouds of gas and a cluster of several million stars, right? So pretty interesting things that actually happen in the very center. So one of the interesting things is that there is a central radio source, okay, and we have constrained its size to be pretty tiny, right? So this is tiny. It's less than 300 astronomical units, and it also flares in X-ray, right? So it's also an X-ray source, and the X-ray luminosity is about 10 to the 5 times, right? So this is 100,000 times the luminosity of the sun, right? So 100,000 suns into a region that is basically less than 300 times the distance between the sun and the earth. Okay, so this is something extremely massive that is concentrated into a very small volume. Now, another thing that we have been able to find close or in the galactic center is then the very few light years. Remember, that's a distance, right? From the galactic center, we have observed in infrared with adaptive optics stars, and we followed their motion, right? And we found periods, right? The period of 10 to 50 years, okay, with Keplerian ellipses. And then we can also measure the distances, basically the same major axis or the average distance from that point, which is kind of dark. I mean, we don't see anything in that point, okay? And that's, kind of tens of astronomical units. That's very important information because we take that with Newton's version . of Kepler's third law, and we get the mass enclosed, right? Enclosed into this is a parsec here, okay? And a parsec is around 3 light years, okay? So tiny region in the sky that is extremely powerful in X-ray and in radio, and also variable. And the variability is important to also constrain the size. So those calculations, and in particular, there is this SO16 star, and here are, for example, some of the orbits and their measurements in different years, and the scale of all these measurements. These are stars that have been observed with adaptive optics. So this was the star. This is the same major axis or average radius of the elliptical orbit, and we found that it's moving this fast. And remember, that could be 2 pi a divided by the period, so we can solve for the period, and then you use Newton's version of Kepler's third law, and we get the mass of the black hole, the mass of that thing that is black, right? Because not even light escapes. It's a very dark and massive object, and the best explanation for what we find there is that it's a black hole, actually a supermassive black hole. Sometimes they show up like this. Supermassive black hole is around 4 times 10 to the 6, because that's a million. Oh, let's do it nicely. Okay, 10 to the 6 solar masses. This is why it's called supermassive black hole, because now we're in the realm of a different kind of black holes. The ones we talked about so far, when we talked about the endpoints in the lives of stars, those are the stellar mass black holes. But now we found that there are other things in the universe that are behaving like the black holes, but they're much more massive, orders, millions of times more massive, and therefore they're called as supermassive black holes. And as we will see very soon, our own Milky Way is not the only galaxy that hosts such a thing in their centers. There are actually, we believe that all of the massive galaxies must have in their centers supermassive black hole, and I'm going to happily offer you some of the evidence that we astronomers accumulated for the existence of these exotic things in the universe.